Hello everyone. Today we'll be solving a problem that came in GATE 2023 based on electromagnetic theory. So the various solutions that were posted about the problem involved or relied heavily on various arithmetic techniques, including the formula for Zn and very long calculations. So I would propose a solution that involves only visualization using Smith chart. So it is given that the standing wave ratio is 2 for this apparatus. So we can find out the value of magnitude of the reflection coefficient to be 1 by 3 because the standing wave ratio is 1 plus mod tau or 1 minus mod. So we get this magnitude of the reflection coefficient as 1 by 3. The next piece of information that is given is that the distance between successive voltage minimas is 30 centimeters. Now, the distance between successive voltage minimas or successive voltage maximas is lambda over 2, which is one complete revolution of the Smith charts because it is lambda by 2 periodic. So lambda comes out to be 60 centimeters because lambda over 2 is given out to be 30 centimeters. Next up, we have the last piece of information, which is the first minimum is located at 10 centimeters from the load. So if you visualize this piece of information using the help of with the help of Smith chart, you will see that ZL is located at an angle of somewhere here. Because if you travel lambda over 6 in the clockwise direction towards the generator, you will reach here, and this is where all the minimas are. So the value of ZL should be lying such that the angle made is here. So that you travel lambda by 6 and you reach to this point where all the minimas are. Okay, where the angle of the reflection coefficient is 180 degrees, allowing voltage minimas to take place. Here we have voltage maximas and here we have voltage minimas. So we travel lambda by 6 towards the generator to get to the voltage minimas. So the value of ZL should be here. Now they are telling that we realize the ZL with the help of RM and LM. Okay, and they wish to find the values of RM and LM, which of the following combinations works best. So as you can see that this is the angle of ZL, and for RL we can be only at two directions, either here or here. The reasoning for this is simply because let's say we have a transmission line that we have here. The magnitude of the reflection coefficient remains same throughout the line, only the phase changes. So when we are here, this is purely resistive. And since it is purely resistive, the reflection coefficient can be either 0 degrees or 180 degrees in terms of phase. And since the magnitude is fixed across the transmission line for the reflection coefficient, it can be either 1 by 3 or minus 1 by 3. So when it is 1 by 3, we are here because the angle made is 0. And when it is minus 1 by 3, we are here because the angle made is 180 degrees. So we are expected to have two values of Rm corresponding to RL1 and RL2 depicted in yellow and green. So first of all, we have the reflection coefficient minus 1 by 3 and 1 by 3. So the value of Rm is very easy to calculate because it is simply given by the expression of the reflection coefficient, which is ZL minus Z0 upon ZL plus Z0. And we get the two values of Rm as 25 and 100. Okay, so we get at them as 25 and 100, 25 and 100, which are in all the four options here. So we wish to find out the values of the Lm also. What should be the length at which we should place it? So that is found by the help of the fact that ZL lies here and it takes it lambda by 6 to go to this point. So if you consider being here or here when we are at this point for Rm, we need to travel the two distances shown, this in yellow or this in green, to reach to this point. So for RL1, we wish to travel lambda over 2 minus lambda over 6, which comes out to be 20 centimeters. And for green, we wish to travel this much distance, which comes out to be lambda over 4 minus lambda over 6, which comes out to be 5 centimeters. And RL2 was corresponding to tau equals 1 by 3, and tau equals 1 by 3 was paired up with 100 ohms. And since tau equals 1 by 3 was paired up with 100 ohms, it goes with the value of Lm equals 5. And we have these two as the correct answers to the problem. So the main emphasis here is to not solve this problem arithmetically and do not rely on the expression of Zn, the big expression for Zn, and rather solve it by the help of Smith charts. Thank you for watching.